Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can make a parametric grid. As you can see here, I have defined a point for the start of the grid. There is a dimension for the X, which we can change the size. And this is going to go for the Y length. As you can see here, we can control it easily with gene pool, which I'm going to explain in this tutorial. The second lesson is going to assume that we have a series of points in Rhino. Then we're going to convert that into a grid easily. As you can see here, it's going to be 0, 1, 2, 3, 0, 1, 2, 3, which is really useful if you want to make that grid by just defining these points. Okay, let's get started from scratch. What I want to do here first is to go to the params menu and use this gene pool, which can give you a combination of number sliders. You can also just type a number slider if you want to, and Control C, Control V it if you want to make a combination of numbers. But anyway, this gene pool is really easy to use. You can say, for example, I want 3 numbers between 1 and 100 with how many decimals I need here. Okay, so here I can just put it for the X direction and the Y direction. I can also randomize that if I want different numbers. Before we can give this a point, which can be any point we want, let's assume that we want to make a grid with only this the combination of X and Y's. We can simply do that by going to the vector and using the point, construct point. If I give this to the X and give this to the Y, as you can see here, this is not going to give us any correct result, because these points are not connected and they are just moving around from a 0, 0 coordination, and in the X direction we have these different numbers. So what I want to do here is that this is going to be the first X, then this number is going to be added up with this number and make the second X, and then the combination again is going to be added with this number and make the third X. So to do that, you can easily do that by going to the math and using a mass addition. And if you give it here, you can see that the partial result will give you a series of numbers like 85, 164, and 217. So if we use that instead, you can see that this is going to be the first point, the second point, and the third point, and this is going to be the first Y, the second Y, and the third Y. And because these numbers can be different, for example, I can say I want 5, you can see that the points for the last one, because these are 3 and this X is going to go to this Y, this X is going to go to this one, and because the fourth and the fifth doesn't have any Y, it's going to stick to the last number. This is called longest list, and actually Grasshopper is always a longest list. So what you can do here is to just graft one of them. The good thing about this is that it's going to also put the points into groups. So for example, if I graft the X coordinate, it's going to make 3 groups of 5. The reason here is that the X is going to be the head of the group and the Y is going to follow. And if you want to be the Y, the grouping coordinate, you can just graph the Y and it's going to be 5 groups of 3. So you can also do that. If I just connect that with a line, a polyline, you can make it, and you can also use a flip matrix to flip the data. It's just like changing the grafting section and make the grid. So that is how you can make a grid with a series of X and Y's. Because this is going to be this location of the starting point, if I want to move it around, what I can do here is to simply use this point, go to vector and deconstruct it. So I have all of the X and Y's, and what we have to do is to put the X and Y at the head of this. So this is going to give us an additional column. What I mean here is that the X has to be, instead of 30, it's going to be like 74, and instead of 61 for the Y, it's going to be 44. So I'm going to just pick up these numbers. And for the input, I'm going to say first use this X, and then with the shift key add the next one, and also use this y and add these y's. So what you are doing is actually moving around the points easily. This is going to be the first column, the second column, and the third column. And this is going to be the first row, second row, third row, fourth, and fifth. So you can actually easily do that by just defining a point, deconstructing it, and adding it to the inputs. So it's going to be at the head of the numbers. You can see that it's going to start with 30, which was the x of the point, and then add up with other numbers. And now you can just have the grid. So that is for the first lesson. Okay, now let's go to the second lesson. And what I want to do is to define a series of points in Rhino. So I'm going to just make a copy of this by holding down the Alt key and moving it in the X direction. And we can also copy this in the Y direction. And to make it more complicated, I'm going to also rotate them in the Z axis. So we have these points, and I'm going to go to the params menu, pick up these points, set multiple points. And because I want to make them completely random, maybe the user didn't define those points correctly. So we have some challenges also for that. I'm going to select this point, then this point. Points. If I go to the point order, you can see that the order is not correct, and obviously it's going to give us some challenges. And also there is a point list. If you bake it, you can see it's like 0, 1, 2, 3, 4, 5, 6, 7, 8. So that is also a good challenge, and I'm going to just right click and internalize this. So when you open the example file, you have access to this. Okay, what I want to do here is first of all, select a random point on this list. Doesn't really matter. We can go to the set list and list item and pick up this index 0, whatever it is. Maybe it's going to be this point, maybe it's going to be this point, doesn't really matter. For this example, it's going to be this one. And now what I want to do is to find the nearest point to this in the group of points we have here. So I'm going to go to the vector point and select this closest points. The point is which is searching is the point we picked, which is the index 0, whatever point it is. I'm going to change the order at the end so you can see it's going to give you the correct results. And the cloud of points, which is one we want to find, is going to be the points we have defined here. And I'm going to give this count 2. And the reason here is that because we have given this cloud of points to the cloud, this point is going to find the nearest point to it, which is going to be itself, and then it's going to search for the second one. So I just defined 2 points, and we have those closest point here. You can see it here that we have these 2 points. And even if we change the order, the order is completely changed. If I just turn this on, you can see it's not in order, and the first point we selected was here, and now those 2 points is going to be this one. The reason we are making these 2 points and we are selecting them is to make the vector for the grid, and for example it's going to be this vector, and simply I'm going to rotate it down in an X or Y direction, whatever direction you want. So the grid is going to be again an ortho-directional grid. We fix that point as we learned before, and then just bring it back to the transformation, which is a really good example of how you can use this transform and inverse transform tool, which is really cool. Okay, now what I want to do is to set list item index 0 and index 1, which is going to give me those 2 points, vector, and give that vector point. So this vector 2 point is going to make a vector for these 2 points. If you want to see it, you can go to display and pick up a custom vector display preview. The anchor is the first point, and the vector is going to be this vector. So you can see that we have actually selected this vector between a series of random points. Okay, after we have done the vector 2 points, you can also use that for a plane. So for example, if I say we have an XY plane, we can go to vector plane and say align this XY plane with this direction. So that is also a good way of making a plane. This is really useful. For example, if I say surface bounding box, just take a look at this. It's crazy. If I give this point to the content and say union box, because the default is XY, it's going to make this bounding box. But what if I just come and give this plane? As you can see here, this is really great because it's making planes from just defining a series of points. We can use that for orientations. Just for addition, this is not going to be the exact way I'm going to extract the points, but maybe this is going to be a good technique for other tutorials. But let's check this out. I say CP surface and project all of those random points on the box here. It's going to give me a UV point, and then I can go to curve, spline, isocurve, and say bring the isocurves of this box from these UV points. And now you can see that we have a series of curves in the UV direction. This is not the exact method I wanted to go forward, but let me explain here that if I flatten them and use the curve middle to find their middle, because we have some duplicates here, you can go to the vector point, call duplicates, because as you can see here, these 9 points are actually 5. 1, 2, 3, 4, 5. Just right click here and say leave 1. So we just have 1 point. And then you can use the set list item to select the index here. Okay. So this is a really cool technique. I'm going to also put this file for you, because this is one of the methods you can do that. You can actually do solve the parametric examples whatever way you want. So I just wanted to give you that you can use that technique too. And now that you have those lines, the problem with this is that they are shuffled, especially when you make the bounding box and so on. For example, if I go here and show you the order, you can see that it's jumping up and down. If I turn on the point list, it's just like saying 0, 1, 2, 3, 4. So another technique you can do here is go to the vector point and use this sort points, because these points obviously as they go, their X is going to be increased, their Y is going to be increased. So that is going to give you a good opportunity to use this sort points. As you can see here, it says sort points by coordinate X first, then Y, and then Z. And then you can again use the list item to get the index for the sorted points, for the sorted lines. And now if I pick up the middles and turn the point list here, you can see it's like 0, 1, 2, 3, 4. Okay, so that is another way of sorting them. Thought that this is also another technique I wanted to talk about. So let me also know in the comments, what do you think about it? Is it useful? So that's also another way you can do it. And at the end, if you want to go in this way, you can go to intersection, physical, curve, and use these two groups of curves. As you can see here, the first one is going to be intersected with the first one, the second one with the second one. So just graft and flatten. Grafting is going to combine all of those, and flattening is going to bring those points down. And now we can have those points in a grid. We also have that surface thing if we want to use it. And as you can see, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can just define the partition. We want to do that and bring those into a group of 5. So I just wanted to give that technique here, but this is not the method I wanted to talk about. I want to go and use another one, which is going to go here. Let's go back to this part. And if you remember, we just sorted them. We use this closest point, we use the closest point to find 2 points near each other, and then use that for a vector. Okay, how is this going to help us? What you can do here is go to the vector vector, and I'm going to use an angle and find the angle of these 2 points. Let me show you again with the vector display. Vector, the anchor is going to be the first point, and also a vector of y, doesn't really matter, y or x, okay, or -x, whatever, because we just want to bring them into an xy coordinate. So I'm going to say, for example, y. And the most important thing about this angle is the plane. For the plane, be sure to give the first point we have used for the vector point, because the angle, let me show you here. If I don't give that, it's going to be different, because it's going to assume it's an xy plane. It's going to just put it, for example, if you use an xy plane, maybe it's going to use an x, so that's going to give you this degree and not the y degree, okay? So don't use an default plane, just give the point to that, so it's going to be on the point we had here. Anyway, this is going to give you the angle of rotation, and now what we have to do is to just rotate that. Transform, rotate 3D, and I'm going to rotate all of those points. The center can be just that random point we selected. The axis is an x, the z axis, which is okay, and the angle is going to go here. And now you can see that it's going to just bring it in an xy direction. So that is how you can fix it. And now what we have to do is to just make a series of points. Another technique I wanted to talk about is a vector deconstruct point and construct it back again. The z is not really that important, but anyway, we're just going to give that z because it's a 0 anyway. But what you have to do here is to graft x or y. Sorry, just graft it. It's going to combine all of those together, and it's going to give you 81 points. We have some extra points here, so I'm just going to flatten and go to call duplicates and just say leave 1. And instead of 81 points, we will have 25 points. And if I just bake this point list, you can see it's completely working. But the most important thing here is that it's like 0 is here, 1 is here, 2 is here, and it's not in a good sorting point. So what I want to do is to go to the vector, again, point, sort points. That's it. That's all you have to do to sort them in XY. Because we rotate that into XY ortho direction, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to be exactly what we want. Okay, for the last part, which is really interesting, you can use this transform output for the rotation and bring those points back, which I think it's going to be useful. Let me know in the comments, is this also good technique or tutorial? So here I'm going to use the transform components and say, okay, bring all of those points back with a transform. If I give the same transform of the rotation here, you can see it's just rotating it again. But what if we go here and say inverse transform? It's like a negative number of the transform. And that's it. You will have those points back in their location. A good thing is that those points are in order, 0, 1, 2, 3, 4, and so on. Now the last step, which I think is also another good technique, is how can we divide them into the groups. Let me bake those points and delete maybe 2 of this and say set multiple points. The reason I did this was because I wanted to have different rows and columns. Anyway, as you can see, it's working. We have that back in the transform section. But now what we have to do is to put them into a group of 0, 1, 2, 3, 4, group of 5. So how can we find this group of 5? Because if we wanted to say a partition list, we can't say just the user give me a number of rows or columns. We just want it to be completely sorted. We can't say that get the list length here, it's like 7, just how can it find the number of rows and columns? So what I've found here is a really cool technique here, which I'm going to use a polyline to connect them together. And if we use this polyline, you can see that it's jumping up and down. This jumping is saying that we have finished this group and now we want to go to the next group, right? So what you have to do here is to use a explode polyline like that. And then I'm going to just connect a vector to those segments. So if you want to see that what's happening here is that it's actually making these vectors. And now what I want to do is to see where this vectors are actually giving me a jump. You can do that by going to the vector and say the dot product. And what I want to say that I'm going to pick up the first vector. Obviously the first vector is going to be in this direction, which is going to bring us the grid. So I'm going to say what is the dot product of the first vector with all of those vectors, right? And here if I connect a panel, the dot product is going to be a number and not a vector. The dot product is a number, which is going to be the length of the vector A and the length of the vector B multiplied with cosine of their angles. Okay, so if they are in the same direction, so for example, if we have this vector and we have this vector again and we bring it up here, the cosine of 0 is going to be 1. So it's going to give us a 1 output here. So if I go here, you can see it's going to be 1, 1, 1, 1, and then it's going to jump to something like minus, and then it's going to be again 1, 1, 1, 1, and then a jump here. Be sure to connect a number of integer to that because this is a number and now we have to make it an integer. Okay, what you have to do here is to find this number. This is indicating that the group is like 4, 1, 2, 3, 4, and 1 added to this, which is going to be 5, is the group of rows or columns, whatever we want to name it. Okay, so what I want to do, you can do that many ways, just the technique I've used here. I can join all of those in the set text join. It's going to just join them all together. And then what we want to do is to say text split. And I want to split this with a minus because what happens here is that it's going to say 1, 1, 1 minus 1. So we just want to see, here we go. You can see it's just going to split that into groups of, after it sees the minus 1. And we're going to pick up the first one, just list item 0 because we just want that. And how many, the length of this text. So I'm going to say text length, which is going to give us a 4, and I'm going to say x plus 1 because it's just like an additional number for the columns, and now we can use the partition to do that. And now you can see that if I go to the point list, it's actually automatically converted into a grid, which we can use. And as we have talked about this before, you can see that it's going to be a line. And I'm going to also say flip matrix and with the grid. Okay, now you can see that you can have that grid easily with another technique. So that was another way. We used the bounding box and we learned how to use the plane, rotating plane to do that. And another one was completely with numbers, and another technique was inverse transform and transform, which I wanted to talk. Also the dot product and some text technique. Just let me know in the comments, do you have any idea of how we can also solve that? Maybe, I don't know if it's like a set member index. I tried to solve that, but it doesn't give me any good results. So I just thought that this joining splitting is going to be also another way of finding the number of groups. Okay, I hope this tutorial was useful. If you have any questions, just ask below. Remember that you can download these example files all from our website, parametrichouse.com. And remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.